Hello, I am the Code Nomad and today we're going to talk about object pools. Well, what is an object pool? Think of an object pool like a tool checkout counter. Instead of spending time and resources building a brand new and expensive object from scratch every time you need it, like the slow multi-second database connection simulated in the following code, you keep a pool, a container, a set of pre-made, ready-to-use objects on standby. When your application needs one, it simply borrows it, uses it, and automatically returns it to the pool for the next task. And this automatic return is due to the fact that Rust has a borrowing system and an ownership system, which make this easier than you think. Let's have a look at the code. There's my editor, Visual Studio Code, but you can use any editor. I sometimes use Rust Rover, but I'm not paid by JetBrains at all, unfortunately. Let's have a look at the cargo.toml because we need to add some things to that. We start by using the object pool. We're using the ESOX object pool crate because I've written that myself. But ESOX object pool is a bit of a mouthful, so we'll rename it. We'll rename the namespace, so to say. And the package is called ESOX object pool. Version at the time of recording is 1.1.1.2. Let's start. We also need Tokio because we need to await some things. The ESOX object pool works very well with Tokio. Version. Well, I just put in one and all features. Cargo is quite simple to use, and we need some random things. The random number of seconds we have to wait before establishing this connection. But you'll see how this works. This is not particularly difficult. Save it. Now we go to main.rs. It's empty as you can see. And we start by importing or providing the types we need. Object pool. We're going to use a dynamic object pool here. And we need a pool configuration. We also need the thread package because we're going to need the sleep method of this package, sorry. And we use rand rng. Well, that's it. Next, we implement a function to simulate, fake if you want, getting an expensive connection. Establish expensive connection. What do we do here? We first choose random number of seconds. Thread ring in range. Let's do that between 1 and 3. We print out that how long the connection will take. I know if you have a real database connection, this is hard to, but this is just for clarity's sake. And then number of seconds. This will return an I32. Here we wait number of seconds. That's why we needed the thread package. And now I see a problem already. We also need the duration. and we return the seconds. And I should have made it U64. Sorry. It suggested I should use that, but it's not necessary. That's it. Now we're going to work on the main function, which is a bit more involved than this. We start by adding this macro, which should be familiar to anyone using Tokio. It would be async. We start by using the pool configuration, by making the pool configuration. So pool configuration new. I'll explain later what this is. You see, I'm using a fluent pattern, active objects, idle timeout. That's why we needed the imported duration, because we're using it more often and with timeout duration from 5. That's it. What does this all mean? Well, the max pool size here, that's the number or initializes the maximum capacity of the pool. It's 200 in this case. You can do whatever you want there. We don't want them all to be checked out all at once. So what we could do here is say, make this 50. Only half of all objects could be active. Because we're using a dynamic pool, and you'll shall see later what that is, if an object sits idle for more than this duration, 10 minutes in this case, it is removed from the pool if it's not checked out. And if we can't get an object for, say, 5 seconds, if it takes longer than 5 seconds, it all depends on the kind of object, kind of environment. I'm saying 5 seconds here. Then we time out. Now we're going to get onto the pool itself. Let's dive in. Pun intended. Make a dynamic object pool. Say new. And we provide a closure. And we print out some message. Probably would do this in a log in production. Establishing new connection. And establish expensive connection. Next, we also provide the config, because we made it and we could as well use it. We also need it. Otherwise, if we don't, for instance, say maximum number of active object or the capacity, then it will continue making new object. That is not what you want. Then a code pool is rather hard to get into, so we warm up async. We put 3 objects in the pool, originally, await, and unwrap. I'm not a big fan of unwrap, but for simplicity's sake, we should do it. Could use it here. Let's check if we have the number of objects. I'm going to use this variable later on and change it. That is why it's mutable. Again, I'm not a fan of mutable. Available count, and we print out the number of available objects. Next, we open a scope. And why do we need this? Well, why do a scope? Meanwhile, if we get an object in this scope and the scope ends, the drop rate will be called and the object will be returned to the pool immediately. So let's get a database connection. Move the cursor, looks a bit strange. Pool get object async await. As you can see, my IDE gracefully indicates we get a result object, which is great, which is one of the great things about REST, I think. Results and options. Because you can't just ignore them, you have to handle them. Let's have a look at the happy path. I always like the happy path. We get a connection, it's okay, and we want to get the contained value. Because as you see, the connection is of type pooled object. A pooled object is a container, it contains the value, in this case a U64, but it could be anything really, and it has a reference, amongst others, to the pool it came from, so it can return to the pool. Without a reference, that is pretty hard. We get a borrowed reference, borrowed variable to the value, and we print it out. Now we want to know, we got one from the on the pool, so let's have it out. This should be one less than the original number. Of course, the compiler will complain, rightfully, and this is of type pool error, and we print out failed to get connection and the reason it failed. It could be that there's a timeout or there's another thing or memory is failing, whatever. That's it. Now we want to check if it has returned the object, because at the end of this scope, and that is this scope, I'll highlight the scope in total. The drop should be called, the drop rate should be called on the connection. It should be dropped because it goes out of scope, and the thing should be returned to the pool. Saved. This is saved. Let's first check if it builds. And we can run it. As you can see, we have the things are initialized. That makes startup a bit longer. That is true. But we have 3 objects available. The first object into the pool at the value 1, and we see that here. We also see that the number of objects in the pool has come down by 1. And we also see that it is returned once the scope ends. That's it. That's how simple it works. There are loads more options, and I will do more videos on this crate. But this is the basic functionality of this crate. I hope you enjoyed it. If you like it, please subscribe and like, and I'll see you in the next one.